Printable Science presents a 3D printed hobby knife handle. Does the world really need a 3D printed hobby knife handle? Probably not. You can pick up a name brand hobby knife for $3 or $4 and that includes the blade. On the other hand, this handle uses only about 25 cents worth of plastic, and if you're like me, there's probably a couple dozen of these suckers lurking around the office and the shop, which I can never find when I need one. So the economy and convenience of just printing a new one when I can't find one results in significant savings over time. Now, the origins of the modern x-acto knife, or the modern hobby knife, can be traced to the x-acto Crescent Products Company that was founded in New York in 1917 by Polish immigrant, inventor, and businessman Sundel Donager. Initially, the company made medical syringes and then moved into the manufacture of scalpels with interchangeable blades. The story, as best as we can determine, is that sometime during the 1930s, an in-house designer's need for a sharp edge to touch up an advertisement was answered by Mr. Donager's design and fabrication of a knife handle with a replaceable blade. I presume that in developing his design, he borrowed heavily from his experience as a medical scalpel manufacturer. Nevertheless, he came up with an ingenious solution for securely clamping a blade into a holder. The mechanism is quite simple. It consists of a blade that slips into a shank that has collet jaws with a tapered outer edge. On the other end of the shank is a threaded post. The shank slips into a collar, and in turn this assembly of blade, collet and collar is screwed into a barrel that has a recessed knockout for a lip on the sleeve and an interior thread to mate with the exterior thread on the shank. Turning the blade forces the shank deeper into the collar, and when the shank collet engages with the top lip of the collar, and due to the tapers on the outside of the collet and inside of the collar, it begins to force the sides of the collet together. The deeper the shank is screwed into the barrel, the more the collet jars are forced together by the edges of the collar until the blade is held so firmly it cannot be jiggled about or removed from the handle. While the first x-acto knife may have been developed in the 30s, it seems that the x-acto company didn't get around to marketing the product until after they applied for a patent in 1946, which coincides with the year that advertisements for the knife first began to appear. It wasn't until March of 1949 that the patent was granted, but in the intervening years, they could always boast patent pending to keep competitors at bay. When we compare the patent drawings with the first advertisement for the x-acto knife, we can see that while the blade locking mechanism remained static, the diameter of the handle was reduced until it was simply a small cylindrical tube with a diameter more or less equal to the thickness of the blade, or width of the blade. Today, x-acto exists in name only, really. The company continued to market and manufacture their hobby knives until 1971, when the company was bought by the Columbia Broadcasting Corporation. Yep, I know. Oh well. And then the Hunt Manufacturing Company bought the x-acto brand and product line from CBS in 1981, and then Berwyn Holdings bought the Hunt Manufacturing Company and Elmer's, the glue people, and pulled the x-acto product from the Hunt Manufacturing portfolio, stuffed it into the Elmer's product line, where it remains until this day. Finally, in 2015, Berwyn sold off Elmer's to the Rubbermaid Company, and that's where things currently sit. From our perspective, the only thing that's relevant in all of this is that while the patent for the x-acto knife expired in 1964, so that we can copy it freely, the x-acto name is still a valid trademark, and so we can't call our thing an x-acto knife handle because it isn't made by the company that owns the x-acto trademark. Fair enough. Only a handle made by x-acto is an x-acto knife handle. But it means we have to fish about for a non-ambiguous generic name so that we can't be accused of trademark infringement, and yet is descriptive enough that people know what kind of knife it is. A bit of Googling reveals that most people refer to this x-acto-like knife as a hobby knife, so that's what we'll call ours. Designing a 3D printable object for a hobby knife is pretty straightforward, but it will stretch most consumer 3D printers and slicers to the limits of their printing ability. To begin with, the thread diameter of the shank is only 3/16 of an inch, and that appears to be about the limit of a thread you can successfully print with a consumer level FDM printer. The barrel itself is only about 8 millimeters in diameter, but it's fairly long, and you might have some trouble with that if you've got a lot of wobble in your Z-axis. Now, as you probably know, at Printable Science, we strive to make our designs as accessible as possible, and we endeavor to stay within a maximum build volume of 90 cubic millimeters when we can, so that even folks with small printers can still print interesting and useful objects. Unfortunately, the length of the classic hobby knife is 100 millimeters. So for smaller printer owners, we split the handle into two pieces so it can be printed on smaller machines. This also reduces the impact of Z wobble, as our pieces are not as tall as they would otherwise be. We took advantage of the height limitation and added a little collar where the two pieces join, which if you print it in a different color will serve as an attractive identifier for your hobby knife, particularly if you work in a shared work environment. Now, when printing things, we know the frustrations of committing your printer to produce something only to discover that it doesn't even work. To help you avoid that possibility, we've included a test file that your printer will polish off pretty quickly and allow you to test the components of the hobby knife before you commit your printer to printing off the complete design. The biggest challenge will be reproducing the very thin walls at the top of the collar and barrel, and this will be left to the sophistication of your slicer. Simplify 3D slicer users will want to ensure that in the Advanced tab you have selected Allow Single Extrusion Walls for the external thin wall type and Allow Single Extrusion Fill for the internal thin wall type. If you're having trouble getting your slicer to produce these thin walls, then leave a comment below and we can try and provide you with some help. For our test file, we set our slicer for a 0.4 millimeter nozzle width, 2 millimeter Z or Z layer, 2 outlines, 3 top and bottom layers, and a 20% infill. But please note, 20% infill is a good choice for all parts of the handle except the shank. When you're printing the final parts, you'll need to either print the shank separately with an 85% infill and the other parts at 20% infill, or print the whole batch at 85% infill, but that of course will lengthen your print time dramatically. The test file is composed of 3 different pieces: a collar test, a shank test, and a barrel test. First, you'll want to make sure that the thin walls print properly. There's no point in committing to a longer print if your printer's not tuned well enough or your slicer is not sophisticated enough to print the thinner walls of the design. So check the collar and barrel test pieces to make sure your printer is reproducing the rim at the top of each of those. Secondly, slip the collar test into the barrel test so you can check that the collar rotates freely in the barrel. Freely, but not with a lot of slop. Thirdly, you'll want to use a number 11 knife blade and the shank test to make sure that the knockout for the blade is wide enough for the blade to fit, but just wide enough. You don't want a lot of clearance between the blade and the collet jaws. Finally, you can try and thread the shank test piece into the handle test piece. It should be a little stiff to begin with. That will become even looser over time, but you should be able to tighten and loosen the thread without it breaking. If your test print passes these tests, then your printer should have no problem printing the entire project, except for the possibility of an unacceptable Z wobble, which really can't be tested unless you print a tall, thin cylinder, which in this case happens to be the majority of where your printer is going to be spending its time anyway. If your test print didn't pass the test, let us know so we can better be informed about the kind of files that will and won't work on your machine. In addition to the comments about infill percentage I made previously, you'll also want to make sure that your print bed always includes a second copy of your tallest piece. If you don't, you run the risk of getting a soft ice cream fail at the top of your tallest piece, and anyway, the tolerance of these parts are fairly close, and although printing them may not result in a dramatic failure, there's a good chance that without sufficient time between each pass of the extruder, these small diameter cylinders are likely to produce parts that are out of tolerance. If your test print was successful, then print the complete 6 pieces of the handle and you're ready for the assembly. The default hobby knife handle implementation itself consists of 6 pieces: the shank, the collar, the 2-piece handle, a small circular spacer, and then a handle cap to cover the blade and protect you when you're not using the knife. We printed our hobby knife holder in silver. This filament is about as silver as this glue stick is a banana. We set our slicer using the same setting as our test piece. The footprint of each of these pieces is not large, but we didn't have any problem printing off the collar or barrel on any of our 3D printers, but the knockout in the shank appeared or turned out to be just too much to handle. There just isn't enough material for the bed to get a solid grip on it, so we added a single layer Z brim or Z brim to the bottom, which we can remove after it's printed. If you're a Printable Science Patreon supporter, you'll want to drop by our Patreon page where you can learn how to download an STL file that will print the handle at the classic length, but that will require that you have a printer that can print at least 100 millimeters high. You can also check out how to download an STL files for printing a hobby knife for the number 2 blade, which is has the same classic design as the one for holding a 11 blade, but it's larger enough and big enough to hold the larger blade. Interestingly, the greatest design effort was for the safety cap. Just printing a cylinder to stick on the end was unsatisfactory, as after repeated use the cap would just slip off the end. We then went for a collet type gripper. It was effective but didn't look all that attractive, and the exposed fingers of the collet were fragile and would break easily. So we finally supplemented the collet approach with an exterior shield, and in practice this works quite well. So in there are some collet teeth that are protected by this outer cover. I guess you could say we're really proud of that. The shield protects the collet fingers during insertion and removal, and yet maintains sufficient friction so that the cap stays on even after many uses. Now, first of all, you should glue the 3 pieces of the handle together. We use epoxy to do this, as we need a very strong joint, because in actual use, most of the strain force on our knife is going to be at the join point of our barrel halves. So if you haven't watched it already, I recommend you check out the Printable Science video on printing your own epoxy workstation. You'll find it helps in your gluing chores for this and other applications. There's a link to that video right here. I'm hoping right here, somewhere. We just mix up a bit of epoxy, spread it on the post, slip on the decorative ring, and then push it into the upper barrel. Don't forget the decorative ring. Even if you haven't gone to the trouble of printing one in a different color, you still need a collar for spacing purposes. So we'll pause now and give the epoxy the time to set, and when that's done, we'll come back and complete our assembly. Well, I think we've given things enough time to dry here. The next step in our assembly is to prepare the shank by removing the brim from the top of the collet with sandpaper or a file or perhaps a sharp knife. We use a large file for this purpose, and it usually only takes a few seconds of filing before the brim falls off, and maybe a couple more swipes until the collet knockout is fully revealed. At this point, you might want to check the collar fit in the barrel, even though your test print should have revealed any problems. This part of the assembly should turn smoothly. It's okay if it's a little stiff. A few more rotations or perhaps a touch of a file or sandpaper should clean things up so that it slides easily. As for the shank, it's best to screw it in and out of the handle a few times. That will help to seat the shank in the handle thread properly and shear off any stringing that may have occurred during printing. While the thread created by your printer is not very strong, you don't need a lot of force to seat the collet in the handles, so don't over-tighten the collet, and it should last a long time. As a last step, we just take a knife blade, slip it into the collet of the shank, and then screw that assembly into the handle until the blade is held firmly in place. There you go. Your 3D printer hobby knife holder is ready for work, and we can put our protective cover on there like this. As a bonus, we've also included a file for printing a hobby knife workstation. It provides a place for you to park your knife when it's not being used, and also some slots around the front to hold replacement blades, and little tray area in front to hold discarded ones. It's a simple object that we printed in PLA with a 2mm Z or Z layer, 2 outlines, 3 top and bottom layers, and a 20% infill. We hope our hobby knife holder is of use to you and that you find it helpful for your hobby and craft needs. Thanks for watching. Won't you help by becoming an important part of the Printable Science family and making this channel more valuable and successful? You can help us out by taking the time to watch this video in its entirety and other Printable Science videos as well, while perhaps your 3D printer is printing off this project. Please leave comments and questions below. That will help us to continue to create useful videos and 3D STL files that are printing ready and help you to maximize the power and utility of your 3D printer. Your feedback is very important. If you've enjoyed this video, please click the thumbs up button. And if you have just a moment, won't you show your support by clicking the subscribe button below? If you want to make sure you don't miss our incoming videos or our upcoming videos on 3D printing, you'll want to click on the notify bell as well. And please consider supporting Printable Science on Patreon using the link supplied below. Being a Patreon supporter provides you with lots of extras and additional information, as well as going a long way to defray the cost of making these files and videos. Down below, you'll also find a link where you can download a copy of the STL files from Thingiverse so that you can print your own hobby knife handle, workstation, and related files. You can also always download a copy of the STL files directly from our website. The latest files and a discussion board on the hobby knife handle and stand are available at the printablescience.com website, where all the science that fits, we print.